In the previous section, we talked about factoring by grouping. And in the video, we didn't work out all of the examples, but on your own, you worked through 4, 5, and 6. And on number 6, if you looked at the notes that were posted, then what you hopefully saw is that we needed to add in the b term because it doesn't exist right now. So in this case, if we rewrite this, what we see is that we have 0x, which means b is equal to 0. So to factor this by grouping, we multiply a times c and we get negative 36, and then b is equal to 0. So the question is, what multiplies to negative 36 and what adds to 0? Well, those numbers have to be opposites of each other. So that's going to be 6 and negative 6. If I add those, I get 0. If I multiply them, I get negative 36. So what we're going to do is take the 9x squared, remove the 0x, replace it with plus 6x, minus 6x, and keep the minus 4. Then we split our group of 4 into 2 groups of 2. And we look for a greatest common factor. So out of the first 2 terms, I could divide out a 3x. That leaves me with 3x plus 2. Out of the second one, I know it needs to be negative because it starts with a negative. And I could divide out a 2 from each of those. So if I divide out 2, a negative 2, I'm going to get positive 3x and a positive 2. Now I divide out my common factor and I get 3x plus 2 times what's left, which is 3x minus 2. This is a very special factoring example, okay? It only has 2 terms, and both of those terms that we started with were perfect squares. 9x squared is a perfect square, and 4 is a perfect square. And look at the pattern that we ended up with, 3x plus 2 and 3x minus 2, okay? If we recognize this pattern, we can take a shortcut in factoring. This special example is an example of the difference of 2 squares. So the difference of 2 squares factoring pattern is this. Whenever I have 2 perfect squares being subtracted, they will always factor to a plus b times a minus b. Now we might recognize that pattern. Those 2 expressions are conjugates. So a squared minus b squared always factors to a plus b, a minus b. So we're going to ask ourselves a series of 3 questions. Are there 2 terms? Are they both perfect squares? And is there subtraction? If you get 3 yeses, then you can factor using this shortcut, okay? So let's look at number 7. First question, are there 2 terms? Yes, x squared and 16, check. Are they both perfect squares? Yes, x squared is a perfect square because we are squaring x, and 16 is a perfect square because we are squaring 4. And then the third question is it subtraction? Yes, it is. So since we've gotten 3 yeses, that means we can quickly factor this to be x plus 4, x minus 4. It's the things that are being squared. The end. We didn't have to do grouping. We didn't have to do any of that. X plus 4, x minus 4. The order also doesn't matter of the 2 factors. You could do x minus 4, x plus 4. That's fine. 2 times 3 is the same as 3 times 2. Multiplication is commutative. And so that would be fine if you do the minus before the plus. As long as you have 1 of each, you're good to go. So go ahead and think about number 8 yourself. So first question, does it have 2 terms? Yes, it does. Second question, are they both perfect squares? Again, yes. What are we squaring here? We're squaring 3 and x. That's how we get 9x squared. And we're squaring 7 to get 49. And then, is it subtraction? Yes, it is. So think about what the factors would be. 3x plus 7. 3x minus 7. Ta-da! Think about number 9. Does it have 2 terms? Yes. Are they both perfect squares? Yes. Is it subtraction? Big fat no. It is not subtraction. And so the answer to this question is that it is prime which means it is not factorable. Those two words are sometimes used interchangeably. It depends on the book or the assignment or the test, how it's going to be worded. So you could use one in place of the other. Recognize both. It is not factorable. And this is an important point, is that the sum, meaning addition, of squares is always prime. Okay. It's never factorable. You could try to factor it by grouping. It's not going to work. When you set up your little X, you're not going to be able to find numbers on the side. Only the difference of squares is factorable. That's really, really important. Okay, let's talk about a couple of other things that are helpful to us when we are factoring. So, a greatest common factor. It is really helpful to us to simplify our work at the start by looking for a greatest common factor at the beginning. We've already talked about greatest common factors when we factor by grouping, but sometimes we're going to start with an expression that's a little bit uglier than we realize. If we start by taking out a GCF at the very beginning, then we can get a simpler expression that's easier to factor, and we'll get smaller numbers. We always want to make sure that all of our expressions are factored completely. And so by taking out any other common factors that we can at the beginning, it saves us some steps. The GCF will be part of the total collection of factors at the end. So if we look at number 10, if I look for a GCF first, and this should be our first step for all factoring problems, if I look here, I notice that every single one of these terms can be divided by 2. So I'm going to start by dividing everything by 2. And when I do that, I get x squared plus 3x minus 54. Okay, so right now I have two factors. 2 is a factor, and x squared plus 3x minus 54 is a factor because they're being multiplied. But now what I want to check is, can I factor this any further? So we're going to do a little bit of work on that. The 2 is going to be part of our final answer, but we want to see if we can break that apart anymore. So we'll work just on what's inside parentheses. This is a 1, so 1 times negative 54 is negative 54. And b is 3. So let's see what multiplies to negative 54 and adds to 3. I think that's going to be 9 and negative 6. So we get x squared plus 9x minus 6x minus 54. Break it up. I can factor out an x, and I get x plus 9. I can factor out a negative 6, and I also get x plus 9. So inside here, I get x plus 9 times x minus 6. And now let's come back and put it all together. So I have the 2, that was my first factor, and now I have the 2 blue factors that came from my original second factor. And so this would be our final answer, and this last one is of the form that is now factored completely. The first green step is factored, but it's kind of like if I say, oh, I have 10/20ths, and I simplify that to 5/10. Well, that is simplified, but it's not the most simplified because I could keep going and simplify that to 1/2. We always want to factor as far as we possibly can, okay? So looking at number 12, this has one that, again, I notice I can divide everything by 2, but I also notice that everything also has a term of x. So this one, I'm going to factor out a 2x. And let's see what happens when I divide everything by 2x. I'm going to get x squared plus x minus 2. All right, pause your video and see if you can try factoring that second green factor now, just like we did in blue, and see if you can write your final answer. There you go. That's what you should get. X plus 2, x minus 1 is what that factors out to. Now, In these two examples, when we factored out, you might have noticed another pattern here. In both of these cases in the inside, we ended up with a case where a was equal to 1. And look at what happened here, okay? The two numbers that I got on the side ended up being exactly what left in my factors. Same thing over here, positive 2, negative 1, plus 2, minus 1. So did I even need to do all that grouping here? In these special cases, no. In the case where a is equal to 1, and this is only when a is equal to 1, this is really, really important, we can cut down on our work quite a bit. So this is example 5, again from up above. Okay, let's think about this. We can jump straight through. Whenever a is equal to 1, the first thing I want you to do is label it. Tell me that you notice it. So right away when I see a problem like this, I'm going to label it as an a equals 1 quadratic. Okay, show me that you know that. That unlocks your shortcut, okay? So when a is equal to 1, 1 times 15 is 15, and b is 8. My side numbers would be 3 and 5, because 3 times 5 is 15, 3 plus 5 is 8. Here's the shortcut because a is equal to 1. My factors will just be x plus 3 and x plus 5 because they're both positive. Done and done. That is all we have to do. Again, you can go back and look at example 5 and see the way we did it by grouping, but anytime a is equal to 1, we can take this shortcut. Now again, when you notice it, you need to say it. It's kind of like, that's the way you unlock this cheat, is to be like, ta-da, a is equal to 1, power unlocked. And then you can use your shortcut there, and you just take the side numbers. You have to say a is equal to 1. That allows you to skip the grouping, but that's a really powerful shortcut when you catch it, okay? So today was all about some factoring shortcuts, difference of squares, and then GCF, which helps you make the numbers a little bit smaller when you need to, and then your a is equal to 1 shortcut. So that's what you're going to be practicing today.